All right, we are looking at lesson 2-4, rational numbers. And I'm going to do a little review just so you understand how this ties into the other lessons. Do you guys remember our Venn diagram? I'm just going to do a quick one here. You could do it a sketch on your paper. What was the first set of numbers that we looked at a couple days ago, a few days ago now? Remember? Natural numbers. You naturally count 1, 2, 3, 4, 5, 6, 7, so on and so forth. And then you have another set that encompasses that first set called the whole numbers. And that simply includes the number, what's the extra number? Yeah, zeros added to that. So you have 0, 1, 2, 3, 4, 5, so on and so forth. All right. What's the next set of numbers that encompasses both of those? Integers. And how would you describe an integer? Remember? What's the definition, Josh?
All the whole numbers and their opposites.
Good. All the whole numbers, 0, 1, 2, 3, 4, 5, into infinity, and their opposites. And now we're talking about rational numbers, which encompasses all of those. Now, there are technically other letters we use for those sets, but I'll stick with those because we can understand that pretty easily. All right, let me ask some questions here. Are natural numbers rational numbers? According to this diagram, are natural numbers rational numbers?
No.
Oh, so I heard the two. It's yes. You see how rational takes up all three of these? So yeah, rational, natural is in there. Are integers rational numbers?
Yes.
Yes. Are integers always whole numbers? No, and you can see how that diagram helps us to know what can be included and what is not included necessarily. Okay, but we really need to know what is a rational number. So can somebody read me the definition of what a rational number is on the first page? It should be in a yellow box. Page 93. Definition of a rational number. Ellie?
A rational number is a number that can be expressed in the form a and b, where a and b are integers and b is not equal to 0.
Whoa, that's a mouthful. Okay, any number that can be expressed. So any number, and each word in that definition means something. It's not like we should have said any number that should be written. No, any number that could be or may be written. No, it says any number that can be expressed. Can be expressed as a fraction of integers. And I'm rewording this a little bit differently, but we'll go back and forth for the two. So any number that can be expressed as a fraction of integers, watch you. And actually, this will clarify it. In the form a over b, where a and b are integers and b does not equal 0. Man, that's a lot. There's a shorthand way, by the way, of writing this, and it's very helpful just to kind of make it really concise. This is the long way of explaining it. We'll get to the short way later. Okay. Any number that can be expressed as a fraction of integers, a over b, and this is the main part, where a and b are integers and b does not equal 0. Okay, let's start looking at some numbers and seeing if they fit this criteria. The number 4. So is 4, according to the definition of rational numbers, a rational number?
Yes.
Oh, can that be written as a fraction of integers where the denominator does not equal 0?
Yes.
Give me an example. 4 over 1. Right? Is 4 and 1, are they both integers?
Yes.
Yes. Is this a 0?
No.
No. That 4 is a rational number. Okay, that one's not too bad. Negative 3 and 3/4. Oof, a mixed number. Ugh. Can that be written as a fraction of integers?
Yeah.
And if so, what would that fraction of integers be in this case? So does anyone know? How do I change this to a fraction of integers? I don't know. It is a fraction? Nope, it's a mixed number. Hayes? Negative 15 fourths. Okay? And again, that negative sign can go with the 15, it can go with the 4, or it can go off to the side. But are these two numbers integers? Are these two numbers integers? Yep. Is that a 0? Nope. Is this a rational number then? Yes, this number is a rational number. Okay, now I get that one. Oh, this one. Good luck, guys. 0.25. That's a decimal number. And decimal numbers can be written as fractions. Okay, so what would be the fraction here? 1/4. That is a rational number. Again, the numerator and denominator, are they both integers? Yes. Is the denominator a 0? No. Let me give you another.
What was one that wouldn't be?
I'll give you. Yeah, good question. Like, aren't all numbers rational? We'll see. All right, what about 0 though?
Yeah.
0 is tough, guys. Excuse me?
0 over 1.
Isn't that equal to 0?
Yeah.
Yeah. 0 over 1. Yep. But,
It is not.
oh, guys, I almost forgot. B cannot be 0. The denominator cannot be 0.
A can be.
Oh, yeah, the denominator is not 0. So the numerator can be 0, but the denominator cannot. That is a rational number. And then these problems, I remember giving you last year, 0.3, and they write it like that, but you can use that repeating bar. 0.3333333, so on and so forth, which is also known as 0.3 repeating. Can that be written as a fraction of integers?
Yeah.
Really? What would it be? 1/3. Okay. That is also a rational number. In fact, and this is where I'm going to get to, Josh, your question was a good one. Any decimal number that repeats can be called a rational number. Anyone. If it repeats, it's rational. You guys okay with that?
Yeah.
Therefore, what do you think a decimal number that never repeats is called? It's not rational. James? Irrational. Okay, so IR means not rational. So that's the opposite of rational. So these two can be written as 1/3. It's a repeating decimal number. Do you guys remember that from last year a little bit? Non-repeating, non-terminating, non-terminating, repeating. So there's a difference. Any questions on that so far? You guys, can you identify a rational number? If I showed you one? Okay. Good. Let's draw a number line. Actually, look at the bottom of page 93. Do you guys see that number line down there? Okay. You're not going to have to draw that whole thing. Draw just a number line, and we're going to draw the numbers, a few numbers in between 0 and 1. And we're actually going to talk about this at the end of the lesson. How many numbers are between 0 and 1? That's a great question. We'll figure that out later. Okay. But here, I just want to divide it into fourths. So I'll go here. Okay, that's as best as I can go. Sorry? Yeah, again, when we do it, we understand that it's, arrows on the end. You don't have to, because we understand, the number line is going to end. All of you, I hope, understand that, but here I did it. Okay, and I'm doing it slightly differently from what the book did, but the idea is going to be there. Okay, I have my number line, and I really try to put some numbers in between 0 and 1, and I divide it into fourths. Okay. Let's compare a couple of these numbers. Let's compare 1/4 with 0.5. Okay, we're going to compare them. Do you guys remember what the comparison symbols are? What are the inequality symbols? So what would the comparison between 1/4 and 0.5 be? What's that comparison symbol that goes in between? Benton? It'd be less than. How many of you knew that without the number line? Okay, good. Most of you should know without the number line. How many of you think, even if you didn't know what these numbers were, the number line could help you out? So if I saw the dots here, the number line can help you out. And if that's the case, how? How does the number line help me out to know which one's bigger and smaller? That doesn't make sense, does it, Eli?
the bigger number would always be the farthest to the right.
Good. Okay, when you go to the left on the number line, what's happening to your number? It's getting smaller and smaller and smaller and smaller. When you go to the right, it gets bigger and bigger and bigger. So you can see here without, I don't even know what 1/4 is. I have no clue what 0.5 is, but I see where the dots are, less than. Has to be that way, right?
Yeah.
Do you guys understand that? Okay, yeah, well, unless you wrote the wrong things, exactly. Let me give you another one here. Let's go with 1 and 15/20. Okay, how does 1 compare to 15/20? From the number line, boom, what is it? Everybody, ready, set, go.
Greater than.
What? How do you guys know that? Oh, yeah. That's 20/20. That's 15/20. 20 is bigger than 15. Yeah, greater than. Again, the number line right here tells you that this number is bigger than that number. Greater than, right? Let's see here. I'm going to give you a tricky one. Ready, guys? Ready?
Oh, that is hard.
Harper, what is the answer? Sorry? So what symbol goes in there? Equal to sign. What? Oh, okay, fine. Yep, that's it. Got it. Okay, they have the same value. In fact, you know what? I have something to tell you. This is not in your notes, but this is something you do need to understand. There's something in math we call trichotomy axiom. Okay, let's take it. What does tri mean?
3.
Cotomy, division. 3 divisions. Axiom is like a theorem or something we have. When you have any 2 numbers, what are the only 3 ways you can compare them? You can say one number is greater than for you guys. You can say one number is, or you can say one number is. Okay, so what I want you guys to do, without consulting anyone else, on your paper somewhere, just write a number, your favorite number, any number, something pops up, positive, negative, fraction, decimal. Write something down. Don't. What'd you write? No, just your own. Okay, so you have your numbers, and I'll just pick on some. I will pick somebody. Swivl, not on. Okay, Riley, give me your number. 12? All right. Lizzie. 17? Somebody give me the comparison. Boo! Yes, less than. Good, good. That was so quick. All right, did anyone write a fraction? Taylor? 12 thirds? Okay. And did someone do a decimal? Someone get a decimal? Walker?
42,564.23476 for repeating.
Less than.
Thank you, Walker. We'll pretend it was, I think you said 4,000 something. Yeah, less than. Did anyone, another decimal? 1,006.3842. Did these numbers just pop in your head like, wow, I want to.
That just came in my head.
That is amazing. The creativity in this room. Does someone have a decimal that I might be able to remember? Yes, Josh? 0.7. And Benson? 7.5. All right, what's the comparison symbol? Less than. Okay, we got a lot of less thans. The last class was almost perfect. We had a less than, then a greater than, and then an equal to. Does anyone think they have the same number as somebody else?
Oh.
Like that you wrote down. Okay, Wyatt, what'd you get? 9. Did anyone put 9? Oh, man. Sorry. Ellie? 5. Did anyone put 5? Wow. Oh, you put 5? Leslie and Ellie put 5, and that's an equal to sign. Okay? And we could do this all day, and I know we'd have a blast. Oh, I have this number. But the whole point is you're going to have less than, greater than, or equal to. That's it. Trichotomy axiom, that's any 2 numbers. Okay, enough of that. The number line will help you out to figure those problems out. Okay, go to page 94. Let's just review something real quickly here. I hope you guys get this. By now, you should be to this point. If you're not, get to it quickly. We have a lot of these symbols that we use. What's this symbol called? Less than. And on the homework, by the way, if you don't know that, you're going to write the wrong symbol, and you're going to get a lot of them wrong. So just make sure that's less than. This one is going to be, yes, greater than. Swivl, delete that. Another symbol would be less than or equal to. Yeah, so the trichotomy axiom says that you can either be less than, greater than, or equal to. Those are the only comparisons, but you can try to find something that's less than or equal to, which covers two of them. By the way, you can't say, well, I guess you could. What number is greater than, less than, or equal to another number, right? Because you already know what. What number is greater than, less than, or equal to 2?
2.
Any number. You're not doing anything with that. Okay, and then greater than or equal to. And I should put greater than or equal to. And I don't know if they even write this one down. Yeah, they do. This is a good one. What does that mean? Not equal to. And, oh, guys, I'm giving you a sneak peek of the future. If it's not equal to, what are your options? So out of the 3, it's not equal to. So what are your only 2 options? It can be, or it can be less than, or it can be greater than. Do you see how that works?
Yeah.
Please remember that. You will have to know that later on. Okay. That is intense. Yes. Sorry?
Tornadoes been spotted in the area, so drill. So let's get them all out.
Gotcha. Okay. Swivl, we have to pause here. Part 2 will come next.